Hello and a very good morning. My name is Lokman Hakim Yahya. My number matrix are 211292069. And today I would like to present to you about lab 3. In this lab we have to construct an uncontrolled full wave rectifier. Before I forgot, the objective of this lab is to examine the operation of full wave diode rectifier and to analyze the load effects in full wave diode rectifier. First, we have to construct an uncontrolled full wave rectifier, and as the voltage supply, we use sine wave 20 volt and 1 kilohertz. As you can see in this circuit, we put a resistance 200 ohm resistor as the load, and there are 4 diodes. Okay, firstly after we construct, we run and we can measure. Firstly, we take the input first, the input measure data, and we got a half sine wave, and the average voltage for this circuit in the input is 5.6314 volt. That is the average voltage for this input on the circuit. Next, we would like to measure the output of the circuit, and as you can see, we got also sine wave, but in this kind of form, and the average voltage for this output in this circuit is 11.263 volt. Move on to the next circuit. This is the inductive load circuit, and it is the same circuit as before. This is the same circuit as the resistive load circuit, but we only add an inductor at the load, and this inductor is 8 millihenry inductor. And we get to see the result of the output in this circuit. The average voltage for the circuit is 11.226 volt, 11.226 volt. Next circuit, we have a capacitive load circuit, and as for the result, we got this kind of graph. It went from 0 to 80 volt, and it goes straight to the end. It doesn't have ripple or so on. Maybe a little bit ripple here, and here. And as for the average value, average voltage value is 17.916 volt, and that's all for the capacitive load circuit. And the last one is the capacitor only. We only replace the capacitive load with capacitor only. So as for the result, we can see that it have almost the same as the capacitive load circuit. And as for the average voltage in this circuit is 17.987 volt. Also almost the same result as before. And what I can say about this is why the impedance characteristic of a large inductor in DC and AC, because I want to explain about the impedance characteristic of a large inductor in DC and AC. Okay, for large inductors characteristic, impedance in DC will consider similarly to resistance, which is defined as voltage across an element divided by current. However, in an AC circuit, Z equals to V over I is still used, but V and I were frequently dependent with respect to the sinusoidal voltage, since the larger the inductor, the higher in the impedance. So the current for D1 and D2 will be almost constant as the inductor becomes larger. I think that's all from me today. Thank you.